So today we're going to look at Unit 1.3, and it's on parent functions. And so parent functions are just basic functions, their equation, their graph, the most basic function that you can create uh, for each of these different kinds of functions that we're going to talk about. So we're going to be looking at specific functions for Algebra 2. Some of them are going to be familiar, um, and some of them may be not so familiar to you. There's a total of 8 functions, I believe, that we're going to be looking at. 6 of them we're going to concentrate on today. I'm going to show you the other 2 real quick, and then we have a whole unit on these other 2 functions, the last 2 that we're going to talk about. All right, so the first one is called a linear function. Linear has the word line in it. So this is going to be a line, and its function is f of x equals x. Now remember, f of x is the same as y. So if the function notation is kind of messing you up a little bit, you can always replace f of x with y. Now if we were to make an xy table to see what this graph looks like, what does the graph y equals x look like? You can just pick some values of x. So let's say we pick -2, -1, 0, 1, and 2. All right, now if we take each of those x values and plug them in for x, then we can get the y value. So when we plug -2 in for x, we're going to get y equals -2. So when x is -2, y is -2. And then when we put -1 in for x, y will also be -1. And same with 0 and 1 and 2. Now when we plot these points, -2, -2, so -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2, we can see the shape of this graph. And so this is a line. It's going to go up on the right and down on the left. So it's a straight line. And we can also give the domain. And so if you remember when we do domain of graphs, you can kind of think of always start on the left side. And this is where negative infinity is. Okay, where negative infinity is. And you ask yourself, will that line intersect our graph ever? Well, because of the arrows, we can see that this line will continue on forever, and they will intersect at some point. So that means negative infinity is part of the domain. And then as we slide that vertical line, think of your pencil or a pen, it's vertical, and as you slide it to the right, it's going to continue to hit every single place. And even to the far right this time, okay, when we put it over here where positive infinity is, it's going to intersect our graph at some point right up here. So that means that positive infinity is also part of the domain. Now when we do the range, we look at what horizontal lines are going to intersect our graph. And so we always start at the bottom this time. And always at the bottom. This is where negative infinity is. And we ask ourselves, will that line, that horizontal line, ever intersect our graph? Well, if they do intersect, we can see it. It's about right there. So that means that negative infinity starts off the range, and then as we slide the horizontal line up, we can see it intersects every single place. Even when we get up to the top here, where positive infinity is, they will intersect. So the positive infinity line and our graph intersect each other. So the range is negative infinity to positive infinity, just like the domain. So when we ask ourselves, or we see a function and we know it's linear, we want to kind of sketch out our basic shape. And that's our basic shape. It's a line. All right, so moving on to quadratics. So a quadratic function has the shape of a U. It's a U shape. Right? So then when we make our xy table again, see how this shape comes out. All right, so again, I could just use -2, -1, 0, 1, and 2. Again, this is the same as y equals x squared. So when I put -2 in for x and I square it, I have to remember to do -2 times -2, and that's going to be positive 4. And then put -1 in and square it, that's going to be positive 1. And plug 0 in, 0 squared, that's 0. Put positive 1 in, that's 1. And plug positive 2 in, that's 4. So when we plot these points, -2 and then +4, 1, 2, 3, 4 is going to put us up here. -1, 1, 0, 0, 1, 1, and 2, 4. Now when we connect these, we can see this shape and this U shape. Right? So this is the parent function for f of x equals x squared. So now we want to ask ourselves, well, what would the domain be? So again, as we start with our vertical line on the left side, where -infinity is, we ask ourselves, will that line ever intersect our graph? Well, they will intersect at some point, and that's because the arrows keep going off at an angle at some point, and they will intersect really high, though. So -infinity is part of the domain. And then we slide that vertical line across, and we can see that every vertical line will intersect that graph, even when we get over to the far right, where +infinity is, and we extend that, again, that graph out, they will intersect each other. So +infinity is also part of the domain. All right, so now when we look at the range, we start at the bottom again. So this is where -infinity is. And we can see that the horizontal line will never intersect that graph, ever. All right, so we know -infinity is not part of the range. So we slide this horizontal line up, and we want to see when does it first hit our graph. Well, as we slide up, it's not going to hit until we're right here. This is the first place that it actually hits, and that's at 0. And because of the closed circle, we have to put a bracket on the 0. Now we're going to continue to slide that horizontal line up, and we can see it's going to hit every single time, and even at +infinity. So it's going to hit way up here, okay, where +infinity is. They will intersect at some point, and that's the highest that it's going to go. It's +infinity. Right, so again, you want to make sure that on the quadratics, you remember that it's a U shape. For linear, it's a line shape. All right, so then we're on to square root functions. All right, so square root functions, again, we can use the XY table. Now the square root function has this shape to it. It's kind of like a curve to the right, and you'll see why in just a second. So again, we pick our values, -2, -1, 0, 1, and 2. But when we put -2 in for x and take the square root of it, if you check it on your calculator, it's an error. So that means there's no value for -2. And when we put -1 in, again, there's no value for the square root of -1. When we put 0 in, there is the square root of 0. That's 0. And when we put 1 in, the square root of 1 is 1. Now 2, when we put the square root of 2 in, it's going to be some decimal. So instead of using 2 on the square root, I'm going to use 4. And you'll see why in just a second. Because if I take the square root of 4, it comes out exactly 2. It's a nice number. It's not a decimal that I have to deal with. You could put 9 in and do the square root of 9. That's 3. All right. So when we plot these points, so we can use the 0, 0, because that's an ordered pair. We can use 1, 1. We can use 4, 2. 1, 2, 3, 4, and a 2. Right? You could use 9, 3. But this is our shape. You can kind of see. So it's not a line, it's a curve. It has a slight curve to it, and it's always going to the right. So that's the parent function for a square root. Now, we want to get our domain in there. Again, if we start on the far left, where -infinity is, we want to ask ourselves, will that vertical line ever intersect our graph? And the answer is no. All right, so now we take our vertical line and start to slide it across and find out when does it first hit. Well, it's first going to hit right here at 0. And because of the closed circle, we're going to use a bracket on the 0. We're going to continue to slide our vertical line across, and it's going to hit forever Okay, even when we're over here at positive infinity, they're going to intersect each other because of the arrow. Right? So we're at positive infinity uh, for the last term in the domain, so 0 to infinity. All right, so now we want to look at the range. So we start at the bottom, ask ourselves, will that horizontal line ever intersect our graph? And the answer is no. So we start to slide it up and find out when does it first hit. Well, it's first going to hit right here at 0. It's the first place. And it's closed circle, so we say 0. And then we're going to slide it up. Now we're going to continue to slide up. And even when we're up here at positive infinity, it's really hard to see. But because this arrow is going to keep going up at an angle, they will intersect each other. So we're going to go to positive infinity. So it's 0 to infinity on both. All right, absolute value. So when we have an absolute value graph, we want to think of the shape. It's a V. V for absolute value. All right, so it's almost like the quadratic, where the quadratic is a U shape. Absolute value is a V shape. They're very similar though in their in their in their points as far as the first couple of them. All right, so using our XY table, so again we could use -2, -1, 0, 1, and 2. All right, so now when we take the absolute value of -2, we have to remember absolute value, all it does is make the answer positive. So the absolute value of -2 is positive 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of positive 1 is just positive 1. And the absolute value of 2 is 2. So we're going to go ahead and plot those 5 points. So -2, 2. -1, positive 1, 0, 0, 1, 1, and 2, 2. Right, so we'll connect these with rays, we'll get this V shape rather than a U shape. So there's a couple values here that are similar to these ones right here from the quadratic and the absolute value. All right, so now we do the domain. Okay, we start from the far left. Again, it's always from the far left. And ask ourselves, will that vertical line ever intersect our graph? The answer is yes, because the arrows will continue forever, and they will hit. So we start at -infinity, and then slide it across. It's going to continue to hit forever, even when we get over to positive infinity. So we say the positive infinity. We do our range. We start at the bottom. We can see that that horizontal line will never intersect our graph because the graph's pointing up. And so it's not going to hit. So we slide it up, and it's first going to hit when we hit that 0, that horizontal line at 0. So we're going to say 0, and then it's going to continue to hit forever as we slide that horizontal line up, all the way up through positive infinity. All right, so the domain and the range are the same for absolute value and quadratics. All right, so let's move on. All right, cubic function, cube. All right, so cubic function, kind of like an S shape. It has a little curve in the middle. So it's kind of a cross between a line and has a little curve to it. All right, so let's go ahead, make our XY table, put our values in. So when we put -2 in for x and cube it, we have to remember we're doing -2 times -2 times -2. And that's going to be -8. And then when we put -1 in, that's -1. Put 0 in, it's 0. Put 1 in, 1 to the third is 1. And then 2 to the third is positive 8. Right, so let's plot those points. So -2, so left 2, and then we're going to go down 8. So 1, 2, 3, 4, 5, 6, 7, 8's down here. And then -1, -1, 0, 0, 1, 1, and then 2, 8. Right, so when we graph it, we can kind of see that curve. All right, so then our domain, again, we're starting at the far left, where -infinity is, and It doesn't look like it, but that vertical line and our graph will actually intersect each other. At some point, it's going to be really low, like way down here somewhere, because the arrow goes off at an angle. So they will intersect, just, it's really low on the graph. So they will intersect at negative infinity, and then they will intersect at positive infinity. This one is just going to be really high, because that arrow is going to go off to the right. So positive infinity. Okay, our range. Our range is a little easier to see. Down here at negative infinity, they do intersect. And then slide it up. You can see it's going to continue to hit everywhere, even when we get up to positive infinity. So negative infinity to positive infinity for both domain and range for cubic functions. All right, then cube root functions, almost like cubic functions. So it's going to be this s. It's just going to go kind of horizontally instead of vertically. So let's make our xy table. All right, so here we're looking at perfect cubes, so I'm going to be careful with some of the values that I pick. So let's say I'm going to pick negative 8, negative 1, 0, 1, and then positive 8. Okay, you'll see why in just a second. Now, if I put negative 8 in for x, the cube root of negative 8 is actually negative 2. Right? And so how you do cube roots, kind of like square roots, but cube roots, you're looking for a number that multiplies by itself 3 times that equals negative 8. So negative 2 times negative 2 times negative 2 is negative 8. So when we do the cube root of negative 1, we're looking for a number, same number, that multiplies by itself 3 times that equals negative 1. And that would be negative 1. And then 0, the cube root of 0 is 0, because 0 times 0 times 0 is 0. And then the cube root of 1 is 1. Cube root of positive 8 is 2. So when we plot these points, okay, so negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and then down 2 is over here. Negative 1, negative 1, 0, 0, 1, 1, and then positive 8, so right 8 up 2. It's up here somewhere. Then when I connect them, so it has that curve to it. All right, so then the domain, okay, again, we're starting at the far left. We can see that the graph intersects, so negative infinity is the first value that hits. And then as we slide it to the right, it's going to continue to hit forever, even at positive infinity. When we do the range, again, we start at the bottom. And the graph will intersect this horizontal line on the bottom because this is going out at an angle on the left side. It's going to continue to go down, so they will hit. Likewise, as I slide this up, it's going to continue to hit forever, even at this positive infinity, which is really high up here. This graph will continue to go up to positive infinity. So you can memorize negative infinity to positive infinity for both domain and range on cubics and cube root functions. All right, so let's keep going. All right, so given each of the following functions, identify the name of the function, and then we're going to give the parent function equation. So the parent function equation is the most basic function, which is one of the functions from the top. All right, so number one, since there's a square root in this, we're going to call this a square root function. And its parent function, we're going to say is f of x equals square root x. That's the most basic function that you can write. So we kind of clear out all the numbers and just leave the variable with the square root. All right, number two. Looks like there's an absolute value bars, so this is called an absolute value function. Absolute value. And its parent function, its most basic function, and strip away all the numbers, would be absolute value x. Okay, number three. So I don't see any squares, square roots, cubes, so this is a linear function. function. If you remember lines from Algebra 1 and maybe geometry, y equals mx plus b. That's what this is, mx plus b. It's a linear function, and so its parent function is just f of x equals x. Okay, number 4, there's an x squared, so this is called a quadratic. Right, and its parent function, we're going to say h of x is equal to x squared. Right, number 5, this has a cube root. So this is called a cube root function, cube root. And its parent function, we're going to say j of x equals, and it's the cube root of x. Cube root, make sure you put the little 3 there. All right, and then 6, this has a 3 in there in the exponent, so this is called a cubic function. It's different than cube root. All right, and then its parent function is just x to the 3rd. All right, so let's do 7. All right, so let's see. This looks like it's just going to be a linear function, right? You could put it into y equals mx plus b really easy by distributing and collecting like terms. And so you can see this is in y equals mx plus b form. This is linear. Right, and its parent function, p of x equals x. Number 8, this has a square on it, a 2, that exponent 2, so this is quadratic. Its parent function, f of x equals x squared. Number 9, this has a cube root, looks like. Cube root function. And its parent function, f of x equals cube root of x. Number 10 is an absolute value. And its parent function, absolute value x. All right, so that's talking about the 6 main functions. All right, and I want to just talk real quick about the last 2. So this first one is an exponential function, and you might have done it in Algebra 1, exponential functions, f of x equals some number to the x power, and that b value has to be a positive number, so it's greater than 0, and it just can't be 1. It can be a fraction, like a half or a third. It could be 6, it can be 100. It just can't be 0, and it can't be a negative number. Okay, and it can't be 1. All right, so its graph, its basic function, I'll just put it on here real quick. So this is an exponential function. Kind of curves up. Like, okay, its domain, I'll just use D. It's going to be negative infinity to positive infinity. Its range, this one's a little different because it doesn't hit at negative infinity, and as you slide that line up, it doesn't actually even hit at 0, but it hits above 0. As soon as we pass that x-axis, it will hit. So this is a little different. We use a parentheses on the 0 and then go up to positive infinity. All right, and then this last one, a rational function graph here. So this is a fraction, and its parent function, y over x, its shape actually has 2 curves, one like that on the right and then one like this on the left. So they're like in opposite quadrants or diagonal quadrants. And its domain, it's a little different also. That's why these two are kind of separate for now. It's negative infinity to 0. And then we're going to pick it up at 0 to positive infinity. So 0 doesn't actually hit either one of the graphs. If you draw a vertical line right here where 0 is, it doesn't hit either of them. So that's why we put parentheses on the 0. So it just can't be 0. All right, and then the range. kind of the same way. It's negative infinity to 0, and then 0 to positive infinity. Again, it doesn't hit on the x-axis. Okay, so that horizontal line never hits either of those graphs, so that's why you put 0 with a parentheses. So there's two separate interval notations for domain and range. They're the same, but you have to write two of them. So that's just a little different. All right, so that is it for the notes today.